Hi guys, good morning. I'm Luis Barbosa from Iberia. So we're going to talk today a little bit about GCP and the computational power that they offers with solutions as Kubernetes, compute engine, application engine. So I'm going to have a short presentation here with 3 little demos, or in fact 4 little demos. Feel free to reach me through the chat. If you have any doubts, please let me know. Let me start sharing my screen here. I guess you can see my screen now. So we at Iberia, as a Google partner, we are talking today about GCP and the computational solution that they offer. Talking a little bit more about myself. I started my career back in the 90s with the startup early movement. Then I worked about 5 years in financial market. Then I moved to telecom industry, in which I worked about 10 years. More recently, for the last 5 years, I worked at digital marketing. Then my last year I spent at Google at the digital marketing team. And just last year, I actually had the opportunity to join Iberia to focus on cloud and cloud solutions. In order to be more expert on those topics, I went out and certified myself as data engineer for Google Cloud. And as we also work with AWS, I'm also certified as a solution architect. As Iberia, we have 2 main fronts of working. The first one is what we call revenue protection, in which it comprises the managed service offering, information security and hosting, which means our customers don't need to focus their efforts in terms of managing the infrastructure, even considering the infrastructure is on the cloud. We can do that on their behalf. All security features we also manage for them, and all service related to hosting can do that also. We also have another front called revenue creation, in which we offer application development and DevOps solution with continuous integration, continuous delivery, and a little bit of application development. Our main strong suit is infrastructure management, but also within those kind of projects, we extend to application development. Those 2 pillars we normally support within the 2 main cloud providers that we are currently partners, which are Google GCP and Amazon AWS. I'm talking here from São Paulo. I'm based in Brazil. Our main headquarters are in Virginia. And of course, you support customers throughout all Americas. Talk about Google. Everybody's quite familiar with this very similar user interface. Behind it, there is a large complexity of IT technology. So they service millions of search every single day, indexing billions and billions of servers throughout the internet. And in order to do that, they have to develop their own IT solution, IT technology to be proficient and performant in that sense. Then when it rise and it was born, the features and technology for GCP. And that's at some point, they decided to offer this as a second line of product, another different line of product from Google, another business unit, which is actually GCP. So currently it's estimated that 40% of internet traffic is flow through GCP, which makes sense if you think about that. The 2 main internet host servers belongs to Google, which are Google Search and YouTube. In the last 3 years, Google have invested about $30 billion on their infrastructure. We're going to see a little bit about what kind of structure we're talking about here. And it's estimated that GCP, only GCP itself, serves 1 billion users every single day. When you're talking about cloud computing, regardless of the providers, the provider, whatever it is, Google, Amazon, Microsoft, or whoever it is, there is 5 main elements that always present. The first one is pay as you go. So everything that usually in the past used to be, in terms of IT, a CapEx investment, now is changed to an OpEx investment. So you don't purchase equipment, infrastructure, and allocate that to serve your customers. Now you sublet infrastructure and pay as you use the required infrastructure that you need. And that is also allow you to rapidly grow or reduce, to be elastic. Consider the CapEx scenario. Normally you buy above your current demand, because you assume that the future keep growing and your demands keep growing, and you would like to have enough capacity to serve your customer in the near future. Here, instead of paying in advance for a demand that you currently don't have, you pay as you go. If you start small, it's small infrastructure. If you are getting traction, getting more demand, you can escalate your infrastructure to support the additional demand. Another very interesting concept here is that the whole infrastructure within each provider is shared. So they normally apply the economy of scale. So the unit price for every single resource on average tend to reduce. And that's actually true, or have been true in the last few years. Everything, of course, must be accessed through the network. So as you don't have the infrastructure on premise, on local physical servers next to you, you have to access through the network. So all the time, security is going to be an issue or a concern that all the providers are worried about and have solutions for it. And so every single discussion about cloud, you normally gonna have to discuss a little bit about security. And lastly, all the services on demand and automated. Normally doesn't involve somebody or someone to deploy the solution or the infrastructure that you need, which is also a disadvantage for the CapEx scenario. Not only to invest upfront equipment and solutions, you also have the time to market to receive whatever equipment that you bought, and also deploy it, install, configure, and then have it up and running to serve your customers. To require new infrastructure on the cloud is normally a few clicks away, few minutes, few seconds that to have that service online. Here you can see the Google Cloud Network. Each dot here with a number is what they call regions. For instance, here in South America, in São Paulo, we have a region. In US, you have a couple regions on the East Coast, have another one in Canada, Central area, West Coast, a couple other regions. In Europe, different regions, and South Asia also in Oceania, Australia. The number 3 here represents, number 3 or 4, 2 represent the numbers of availability zones. Availability zones is more or less like a data center. It's not actually a data center because it can be comprised about 2 or X buildings of data centers very close by. And within a region, when you have 3 regions, the idea is that within a region, have different zones away from each other at least 100 miles. That means in case of a disaster or power outage or any kind of problem, the region itself can be also supported for the other availability zone that's available within the local area. And all those regions are connected to proprietary network from Google. You don't have to connect through public internet. You don't have to travel between East Coast and West Coast. You don't have different hops or different steps of servers to get on that server. The connection is almost direct, so the latency is very small. Also, they have these black dots here is what they call edge locations. So for instance, if you are here in Buenos Aires, you want to access a Google network that doesn't exist in Buenos Aires, they're gonna deploy one very soon, probably this year. People from Argentina probably gonna use the infrastructure here in Brazil and São Paulo. So they simply access the edge point in Buenos Aires and are connected directly to the proprietary network, to the nearest region, which is in this case, São Paulo, right? Here's some pictures of the data centers from Google, available zones. They are considered now carbon neutral. They use as much as renewable energy as possible. Normally in remote areas, try to focus on security and availability of the infrastructure. The network itself also connected even through oceans. Here we have a small animation here that actually show a shark attacking a network cable through the oceans that Google offers. So they have, of course, Kevlar support to protect it. And then, as I mentioned, security is a concern that go from every level. It starts from the hardware. So here you have a network interface. Embedded on that network interface, they use a custom-made chip called Titan that's already embedded a set of features for security. And then it goes to its hacks, to the physical access to their building, to the personnel that involved, up to the end user that have to configure part of the security level. So the security is a concern that is taken care or considered every step of the way. Here we have the 4 main services that GCP offers, which are comprised by compute service, storage service, big data, and machine learning. On the storage, you have the database like Cloud SQL, Cloud Storage, Bigtable. On big data, you have service to process a large volume of data, and the database, very famous BigQuery. In machine learning, you have a different service for machine learning, from speech API, vision API, natural language API, and so on. And today, of course, we're going to focus on the computing service. In the compute service, you can have compute engine, which are the traditional virtual servers on the cloud. If you want a new Linux machine, for instance, you can deploy on the cloud a new Linux machine with X amount of memory and Y amount of processing unit. You can have a little demo of it. This is it's normally called IaaS, Infrastructure as a Service. Then, in the other hand, we have application engine, which are considered a PaaS, platform as a service. So you don't concern or you don't manage the infrastructure itself. The infrastructure managed automatically by the cloud. You simply deploy your applications. And in between, we have Kubernetes, or in fact, the GKE, the engine from GCP for Kubernetes, which is a hybrid. You still have the consciousness about the infrastructure that been using, but the infrastructure is virtualized and encapsulated along with the application. And you deploy a whole package of infrastructure and application in a single unit. And lastly, we have cloud functions, which is even more abstract than application engine. Instead of deploying an application package, you simply deploy a small piece of code, and the infrastructure itself, the cloud manage the auto scale of it. So it's normally used to manage microservice. So have different operation, different service, and for each service, you have a small deployment of programming code on it. Today, we're going to focus on the first 3 ones, or then we're going to focus on the 3 main ones. Cloud function, we won't cover today. So what's Kubernetes? So Kubernetes is a container solution developed by Google. It was published as an open source solution. It focuses on automation, the deployment of these containers. I like this image very much. This truck here can move different containers and deploy them physically, automatically. So the same concept in terms of application is used in Kubernetes. Within that containers, you have the application and its infrastructure or its dependencies, and it can operate in two different ways, either declarative or imperative. Imperative means you say, I have this application with this dependency, I want to deploy it in a cluster of X server, 3 servers, and then I want to escalate that to X copy 5, 6, 3 X copies within that cluster. Or you can do it, manage it in a declarative way. You can say, oh, I have this application, I need at least X percentage of processing unit. In case it go above it, please scale up the number of services and the number of deployments. So this technology of containers or Docker is also a specification for containers, has grown in the last 3 years up to 40%, has been increasing very fast. It's a very practical way to manage complex environments within the cloud. And the idea is to, as I said, to have encapsulated application dependence on single package in a container. So if you consider the traditional way in which you have a hardware, operational system, a kernel operational system, dependence for the application itself, you have to manage each one separately, individually. So if you have this application running in a development environment, you want to move it to a production environment, you have to replicate all this infrastructure, have a similar hardware, have to make sure that you have same exact image of this operational system, make sure to install every single dependency in the correct version, and finally to deploy the correct version of the application. Part of it was solved or simplified once you have the virtualized solution, the cloud solution, in which you have the hardware and the hypervisor, which is the virtualized hardware infrastructure. But anyhow, the next tiers of this stack here also have to manage manually. So within the virtualized server, have to deploy this operational system, the dependency, and the application, and replicate that effort once you have the development environment, then the production environment. And now, when you have this idea of containers and Kubernetes, the level of abstraction went a tier above. So the hardware is totally transparent, the kernel, the operational system also transparent, and above those, you have a container runtime. So the developer or development team have to package together the application dependency and deploy it under the containers, which is very useful as the below tiers are abstract. You can develop one kind of operational system, local machine for developer if it's the case, and then deploy in the production infrastructure with very little complications. So one scenario that's quite famous in terms of development is the developer always says, oh, in my machine it's working, and then when you deploy to production or to a test environment or whatever, normally have problems. We're going to simulate a scenario as that in the demo. So the steps involving Kubernetes is quite simple. First step is have to create the cluster with the nodes or the servers that we want to use. So in the example here, we have a cluster with 3 nodes. Then you have to deploy your application. Initially, the application is deployed, one copy of it in one single node. Then at this point, the application is not visible to the end users. So we have to expose it as a service layer. So create a service layer, which is connected to a load balancer. So whatever demand you have, that demand can be balanced in between different servers and different deployments. At this point, we only have the first deployment available. We can also escalate that and have multiple deployments of a single application. And note here that the term that you use is pod. Pod is a composition of cluster. You normally don't deploy a single cluster. If you have different applications, you bundle all that together, and a set of clusters are called pod. You deploy the whole pod. We're going to do that in practice. We're going to come back to those slides. So let's see the demos. Let me start my machine here. I believe you can see it. So I have this very simple code. Let me show you here. The first scenario is to have the application running on the local machine. So that scenario of the developer that always says, "Oh, on my environment is working fine." The application that I'm going to use an example is a traditional Hello World one. So it's a Python application with Hello World on the screen. I put also the date and time to go along with the Hello World message. And to a Python application to work on the web as a web application, we have to use a library called Flask. So Flask is this kind of notation here. So this notation, he maps the root directory for the server to this function hello, which simply returns a string hello world with the date time. Here also, on this attribution here, I'm mapping the port that's running to the server, so the localhost port 80, that's gonna run that application. Let's see that in practice. So I have the application here. That very same application that you saw on this line, very same hello world. You can simply run it by so the local server is going up. Here it is, local server port 8. Root directory, we can see the application deployed. Localhost, port 80, host. So here it is. It's running just fine, as expected. Then you can see that exactly same scenario on the cloud. Then you're gonna use a computing engine. So we're gonna create a new instance, a Linux instance. You can use all the standards information, even the standard name. We're gonna use the US Central Zone, standard machine with one CPU, with almost 40 gigabytes of RAM, Debian Linux as a operational system. The only difference that I'm gonna mark here is to allow HTTP traffic. So of course you're gonna test a web application. So it's creating the server here. I can go back to the slide. And then in that example, you gotta keep in mind, one of the main points that fails once the developer move the application to the different environment is that normally he forgets about all the dependencies. He created the dependence or installed the dependence a while ago and keep developing for weeks or months and simply don't remember what kind of dependence they have on the local machine. And here I have actually mapped what kind of dependencies they're using. Basically is Flask. In order to install Flask, you're gonna use this apt-get tool from Linux and then install the Python. Even the Python is a dependency, have to be installed on the server. And the pip is the library manager from Python. Once you have pip available, we're gonna start install Flask, which is the library that you're using, and finally run the application. Let's see. So we have our server running here. Let's connect to it. Okay, here we are. First of all, let's do all the commands gonna run by as root. So let's make sure that our apt-get is updated. All right, then let's install Python and pip. All right, now we have pip, so you can install Flask. And finally run the, oh, of course you have to upload the application. So the same application here. Let's run it. Right, same thing, it's running on the 80 port from the server here. All right, have the same exact result. Perfect. Let's go then to the third scenario, which is actually Kubernetes. Going back to the slides. Oh, have a funny picture. You see how it was simple to install the libraries in Linux, very organized as actual library. If you're gonna want to do the same exact experience on Windows, probably have a bunch of toolbars, Badu toolbars, or whatever bar you want on your environment. But anyhow, so Kubernetes will involve 3 steps. The first one is to package, to do to build an application with their dependence and then registry with the registry service within GCP. It's going to be the same command to do both operations, and finally use GKE to deploy the application itself, which are comprised of 3 additional steps or sub steps, the same ones that you saw on the slides. So the first one is to create the cluster. Then you have to deploy the application within the cluster, and then scale up the service on that cluster. One small difference that we have here is that you have to use a Docker file. A Docker file is a kind of configuration file that's gonna declare the kind of dependence that the application has. So the first base thing that you have, which is the operational system that you're gonna use. So they say from Ubuntu, latest version of Ubuntu operational system, copy the application, which is basically the hello.py at the root directory. Then run a couple of commands, the commands that have to install the dependencies is the exactly same commands that I just run for the other scenario, in which you have to update the apt-get and then install Python and Python pip. Also run pip to install the Flask library, and finally call the application hello.py with the command or the entry point Python, right? So the command to deploy and to register the application is this. So here you call gcloud build and the service GCR, Google Cloud Register, to register this application hello world. And lastly, we have this dot here, which means the whole content of this are actually going to be packaged and deployed. All right, let's do this. Let's open a console here. Okay. Let's upload our files, the application and the Docker file. Let me remove everything here and do it again. All right, okay. Let's create a directory and then copy those two files to that directory. Okay. So we have here exactly same application. And you now also have the Docker file as shown. So we're going to use the Ubuntu latest installation operational system, copy our application, install the dependencies, then run the application itself. So I run the command to package to build the application, then register on the service. So here on Google Cloud Build, you are running that build, that compilation. Once it's finished, you're gonna see it at the register, gonna show it. Meanwhile, let's create the cluster. Let's create a cluster. Standard configuration also. So standard name, within the zones, US Central Way, GKE version 1.13, 3 server, 3 nodes, standard machine, everything as it is, as standard, right? So we're going through those steps here, right? So first of all, creating the cluster, and once the container is built and registered, the service is going to deploy it, and then expose it as a service, and then scale it up, right? So we are at this point. So I guess it's finishing the compilation, the build. It's finished. We'll be able to see it here. So the build, so the let's build, it's finished 1 minute ago, and probably gonna have the application registered. Container register. So we have the application hello world registered here, the latest version 1 minute ago, right? So that's the one that's gonna deploy it. Let's see if our cluster is ready to deploy. It's still creating. I'm using the graphical interface from GCP, which is quite convenient, but every single thing here can do as a command line. So the command line is represented here. Within GCP also you could get the commands here. Also it's possible to invoke those operations through a REST API. So there is different ways to interact with the cloud, with the GCP. Of course, at least for me, the graphic interface is quite convenient. Couple more minutes, I guess. Seems to be finishing up. So 3 nodes, 1 CPU each, almost 4 gigabytes on each, almost 12 gigabytes in total. The cluster is up and running, so now we can deploy our application. So we're going to use an existing image that we already registered. The image is here, so it's Hello World, the latest version that we built 3 minutes ago. Everything's standard. Continue. The application name I'm gonna call Hello World. The phone namespace. Here you can see YAML file is a configuration file for Kubernetes or GKE, in which they say have all the configuration with three server, 3 replicas of the application. That replicas can go from a minimum of 1 copy of it up to 5. We're gonna then escalate and scale it up to 5 replicas. Let's see in the end. And let's do the deploy. The deploy also takes a little while. All right, seems to be finished up. So, okay, if everything's fine, we have, so we now have, going back to the slide, so we created the cluster, then now we deployed the pod, the cluster, or the set of clusters. And this application is not yet available to the outside world. So let's expose it as a service so we can access it. So let's expose it. Create that service layer. And the traditional 80 port with the load balance, then the name of the service is extended, expose. It's creating load balancing, connecting it to the deployment that we created. To create external IPs connected to the load balancer and the load balancer to connect to the deployments. All right, here it is. So now we have this external balanced IP. Again, port 80. And if everything is fine, the application will respond. Here it is. So it's responding on the load balancer IP on the port 80 on that root service. Perfect. All right. Let's see then our last example. Oh, no, let's then scale up. At this point, we have 3 nodes with a single deployment. Let's scale up to 5 instances. Let's do that. We can go here at workloads. And then we can scale to 3 replicas. Now we have 3, in fact, go up to 5. So as you have 3 nodes, you're going to have 2 nodes with 2 instances, 2 deployments, and another one, oh no, sorry. You're going to have 4 more. Oh no, it's fine. Now we have the total of 5. Perfect, perfect. So this very simple application can now support a huge significance of demand. And then the last example is the application engine. So instead of bundle a whole package or a whole container with all the dependencies, you're going to simply deploy the application and state its dependency on another configuration file called YAML. It's quite similar to Docker file, but a different syntax. Here you say what kind of runtime environment they're using. I'm using Python 2.7, an application that's thread safe, which means it can support multiple users at the same time over the web. Then it maps the root directory to the application itself, and the kind of library depends that you have. The only depends that you have it's Flask on each version 0.12. So the command to deploy the application is this. Going back here, we can now upload the YAML file. Here it is. Let's move it to that directory. On that directory, let's remove the Docker file that you don't need anymore. Let's make sure that you have the application YAML here, exactly as you've seen on the slides. On the application itself, you have to change something a little bit. Instead of stating the actual host name, the local server and the port, you're gonna put it as random, and the app engine is the one that are gonna choose a random port internally and then map the 80 port external to that server. So application engine gonna do it or manage it for us. Let's save it. All right, run the command to deploy the application. It's similar to container, but at some time it's different. As again, we don't have to bundle, to package the application and the whole dependency infrastructure as a container or as a pod. We simply deploy the application, and the application server manage the dependence at the deployment time. At the end of the process, it's gonna put available URL. I guess it's this one. Let's connect to it. Here it is. Same result expected in a different scenario. So guys, I guess that's what I had for you today. If you had any doubts, please feel free to reach me. Here my contact information. If you have any additional thoughts, please send me through chat. If not, please feel free to reach me over my email. Thank you very much. Bye-bye.